So today we're still going to talk about adding and subtracting fractions. This time we're going to try to do it with equations. So we're going to link it to models, but we're going to look at the equations that kind of go with it. So some of you, I think, have already figured this out. You've figured out some patterns and you understand how this works. Let's kind of look at how we can make it not take quite so long with those models, but we can still be good logical math thinkers. All right, so here's our first problem. Mariano recently got a puppy and a kitten for his birthday. The puppy is already 1/3 of a year old, and the kitten is 1/6 of a year old. Which pet is older? How much older? So I have 2 questions. I have to make sure I answer both. I have them underlined so when I go back and check I should be able to do both. How much older? How much older and which pet is older? Okay, so what is this problem asking me to do? Am I trying to add the 2 or am I trying to find the difference between the 2? I'm trying to find the difference. What does the word difference mean? Difference means to subtract. So I have 1/3 and 1/6. Okay, so which one is larger? Let's figure that out. Okay, so we're going to do it with equations, but we're going to try to link it to how I could use just equations. So I'm going to draw my box. I'm going to do 1/3. I divide into 3 sections, right? And I have to color in 1. This time I'm going to do 1/6. Whoops. I should not have drawn my box that large. I'm going to take that away. So I've already divided them this way. I should be dividing them this way. Maybe this was the same pen I used yesterday and it stopped working on me. I wonder. I don't know where my pens go in this house, but they sure do disappear. All right. 1, 2, 3, 4, 5, 6. And how many am I coloring in? 1. I cannot compare these when they are 2 different models. So how am I going to find common denominators? So my goal is to make these 2 have common denominators. What do I need to do to find common denominators? Well, remember I cut this one into 2, 3, 4, 5, 6 parts. So I multiplied it by 6 and I got 18. What did I do over here? I want the same denominator. What am I going to do to 6 to get over to 18? What am I going to do? I'm going to multiply by 3 because I'm going to cut this into 3 parts. So what did I do to find a common denominator? I multiplied this one by the other, and I multiplied this one by the other. So whatever I did down here, remember I also cut this one up by 6. So I'll do 1 times 6, and I get 6. Remember I cut the whole thing by thirds? Well, I also cut this one piece by 3. So my question was, which pet is older? This one was the puppy. This one was the kitten. So which one is older? Here are my fractions. 6/18, 3/18. So the puppy is older. Why is the puppy older? Because it has more pieces. It's larger than this one. This has 3 pieces that are 18ths. This has 6 pieces that are 18ths. How much older? I'm trying to find the difference. So I have to take the difference between 6/18 and 3/18. What's the difference? 3/18. Is there a better way to call 3/18? Yes. What number goes into both 3 and 18? 3 goes into both of those numbers. 3 is a factor of both of those numbers. So I'm going to end up with 1/6. I'm going to end up with 1/6. So let's look at what I did. I found a common denominator by multiplying. Okay, I did the same at the top and the bottom. So let's pay attention. Used the same multiplier. So this number was the same. Over here, this number was the same. Where did I get this number from? This number came from here. This number came from here. So we're looking at the patterns. So we're going to solve the next problem. We're going to not draw a picture and see if we can follow these steps without the picture, just the equations. So here's our next problem. Janice and Chris are working on a project. Janet completed a half of the project. Chris completed 3/7 of the project on the following Monday. How much of the project do Chris and Janet have left to complete? Have left, what does that mean? So if here's my project, this is my project. I'm going to draw a picture to help me understand what I'm supposed to do. Janice completed half. Janice did this. Chris did this. So Janice completed some, then Chris completed some more. So I'm looking for this. So I have to do Janice plus Chris and then find the difference. So I'm going to do Janice plus Chris then find the difference. Then find the difference. Because what is this total? This whole thing is one whole. Alright, let's try to do that. Janice is a half, Chris is 3/7. 1/2 plus 3/7. So I'm going to write my problem up and down now. So I have to try to find that common denominator. What did I do up here to get my denominator? Remember I used the other number to multiply it by? So what number am I going to do with 2? What number am I going to multiply? Remember I have to use the same multiplier here. What am I going to use? This number. So I get 7/14. I use this denominator because remember we had to cut it the other way. Use this denominator, okay? So what am I going to multiply this fraction by? So I'm looking for my denominators is what I'm focusing on. I'm going to use this denominator down here. Times 2 times 2. So what do I get? 3 times 2 is 6. 7 times 2 is 14. Okay? So let's see what I get. My denominators have always stayed the same. I'm not cutting them into more pieces, so my denominator stays the same. So let's note that. Let's write that in our notes so tomorrow when we're doing them we can figure that out. So denominator stays the same. Right here, denominator stays the same when adding or subtracting. It stays the same. So all I have to do is 7 plus 6 gives me 13. 7 plus 6 gives me 13. So what did I do? I found a new common denominator by multiplying the other one. Okay, so what am I going to do here? What was my question again? Remember it was 2 parts? I have to find out what's left. So how much did Jana and Chris make together? And then I have to find the difference to make up the whole project. So how much do I have left for them to finish the entire project? What's the difference to get when they have 13 pieces? How much more do I need? They have 1/14. left of the project. Because if the project was completely finished, it would be 14/14. This is what it looks like for it to be finished. That means all 14 parts are shaded in. So they have 1/14 left of the project to finish. All right, let's see if we can practice just what we did without doing the pictures, but doing this strategy. I also have to consider, should I simplify? You know, 1/14 is as simple as it can get. If 1 is in the numerator, you're done. You don't have any more simplifying to do. All right, let's look. MJ's parents kept track of how tall he is by marking his height each month on his closet door. Let's stop there. So I could see a picture of a closet door, then marking all these heights. In January, he grew this many inches. February, he grew ½ inch. In which month did MJ grow the most? So I'm looking for a month. How much more did he grow in that month? How much more? This means I'm trying to find the difference between the two. So I need the month, then I need to find the difference. 5/8 and a half. 5/8, and I have a half. So I have to figure out which one. The reason why I didn't put these right up above each other, because I'm not quite ready to subtract yet. I have to find which one's bigger first. So I have different denominators. So I have to find a common denominator. I have to find a common denominator. Alright, so remember I'm going to use the 2 over here. I have to bring this 2 over. Times 2 times 2. I have to use the same multiplier. I already wrote that in my notes above. Where'd I get this 2 from? This denominator, because I'm trying to cut my parts up. Remember, this is cut into half, so I have to make this one be cut into a half. So I have 10/16. So what is my multiplier going to be over here? This number. This number. So what do I have to do? I have to cut this one into 8 pieces, going the other direction. 1 times 8 is 8. 2 times 8 is 16. My question says, which one is bigger? This was January, by the way. This one was February. So which one is bigger? 10/16 or 8/16? So January. The question says, in which month did MJ grow the most? January, he grew the most. In January, he grew the most. So my second question was, how much more did he grow? I have to find the difference. When you're doing word problems, I should see you marking this up just as much as I did. I'm writing words to help me remember. So I have to find the difference. So I have to do 10/16 minus 8/16. And that answer is, denominator stays the same, right? It stays the same. 16. 10 minus 8 is 2. Can this be simplified? Is there a number that can go into both 2 and 16? What number can go into both? 2. So how much more? 1/8 more. 1/8 more. Let's do one more, and let's use mixed numbers, and let's see how it's different. So the truck carried, so here's my problem. I'm going to pick one out of here. The truck that carried the elephants hold 10 tons. Which 2 elephants could travel together? So it can hold 10. Which of these 2 could travel together? So I have to name all the possible pairs. I'm just going to find one of them. So which 2 do you think I could add together and it would be under 10? I'm going to look for the smallest numbers. I'm going to try Daisy and Squirt. So what is it? 4 2/3, 3 2/3. 4 2/3, 3 2/3. So I'm adding them together, so I'm trying to find the total. Whoops. Okay, so let's look at how I did. So I lined up like a regular addition problem. I lined my fractions up and I lined my whole numbers up. I lined my whole numbers up and I lined my fractions up. Okay, so I already have common denominators. I'm going to change this problem. Let's just say this problem was different. I'm going to change this, sorry. I'm going to change this to 3/4 so we actually have a good problem to work with. Because if we didn't, then we don't have any common denominator work to do. All right, so what do I have to do? I have to find a new common denominator. So remember what I do? I'm going to use the 4 up here with the 3. Remember, I'm going to use the 4 up here with the 3. I'm going to go times 4 times 4. So what do I get? 2 times 4 is 8. 3 times 4 is 12. Because remember, I'm trying to make them all be the same size pieces. So I have to take my fourths and do it up here to the thirds. What am I going to multiply by down here? Take this denominator down here. Times 3 times 3. So where am I getting this 4 from? This denominator. Where did I get these 3 from? This denominator. It's like you had to share with the other. Okay, so I have 9/12. So I have to add here. Okay, so what am I going to do? I'm going to keep my same denominator. 8 plus 9 is 17. Now I have to come over here to my whole numbers. 4 plus 3 is 7. What do you notice? This number is too big. It's called an improper fraction. It's too big. It can't work. So what does this look like? This looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. It looks like I have 17 parts. But how many parts make a whole? Only 12 of them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is equal to 1 whole, and these are my leftovers. So these 12 make up a whole. These are my leftovers. So I have 1 whole. And how many leftovers? 5. What's my denominator? It stays the same, 12. So I made this equal this. But I can't forget, I have more holes over here. So how many holes do I have altogether? 8 and 5/12. 8 and 5/12. So we are going to continue practicing how to use this model with whole numbers. Okay, so we're going to talk about how to do that some more, and we're going to practice this the rest of the week.